So welcome to the 2025 Fang Robotics Infantry Devlog. I'm Raven Asher Raziel. I'm here to explain what this is and what this isn't. So what this is essentially is a raw recording of me functioning as a programmer in this journey of programming the firmware for our infantry robot in the RoboMasters competition. The purpose for this is to give beginners an idea what is it exactly like to code beyond the tutorial, because in a tutorial it's a very laboratory environment, laboratory-esque, in the sense that there are controlled conditions. There's only a limited subset in order to keep things simple for the beginner to learn these specific blocks of skill, which they piece together. However, once you get past the tutorial, you'll quickly find yourself, as much as you can understand, like, this is uniform bracket initialization, we're doing division and we need a point 0 or else it's going to do some terrible rounding issue if this happens to be an integer. Well, which it is an integer. um, but how does one look at this repository? You have a .vs code, you have the docs subfolder, and just all of these massive configuration files, massive build tools. How do you go from someone who just knows how to speak the language and to someone who can write it, who can breathe it, who can think in C++ or whatever language, even JavaScript? Because there is a massive amount of interaction between various tools. For example, in GitHub or in Git, this help line is extremely detailed. It almost takes up the whole screen. How do you use this in conjunction with this properly? Because there is not necessarily a sole correct manner in how you do stuff, but there are better ways and there are extremely not better ways. How do you work with Git? For example, here I'm able to look at the commit history, the branches, the merges. How does someone utilize that in Harmony? And what are the best practices? Like in our case, I'm using merges. We're not using rebase. The reason for that is that we want a more authentic history. I know this is depending on where you program. If they tell you to use rebase and they're the lead dev, then use rebase. But merging with the branches just shows how different timelines, time streams interact with the features. And if you're trying to hunt errors, they now have git bisect of first parent. If this sounds a bit like French to you, don't worry. Eventually, you will see all of what I'm saying is in action, but the point I'm making is, how do you get from someone who knows the theory into someone who knows the practice? And one of the best ways to learn is through looking at an actual example. And this gets to one of the things this isn't. This isn't a perfect tutorial. This isn't a perfect example. This is a functional, real-life example of how it is to code. So you will see me make mistakes, but you will see me recover from those mistakes or correct those mistakes. Like, for example, when I was initially dealing with data structures, I was having something for translation. I had something for a vector, and eventually I was like, this is code duplication. This still hasn't been removed yet because I'm planning a refactor after just the basic chassis functionality has been implemented and tested. And there are other key mistakes I made earlier on with just basic syntax because I didn't compile as much before committing, which is a good idea, is to make sure that it actually compiles. And at least, especially if before you merge all your things into the development branch, and definitely before things become merged into the main branch. the final well, not the final version, but the most functional version. And whenever I'm doing stuff here, for example, in the unit tests, so that's a philosophy that I will be using heavily and that I'll be using with the whole team, is that there is a way to test this code without having to do the whole dance between uploading it on the robot, and you have to make a large chunk in order to get it to communicate with the robot, which means that if I'm writing code with the chassis logic and I want to test it on the robot, the chassis logic has to interact with the motor drivers, and if those motor drivers aren't even tested, then if something goes wrong, that can be like a needle in the haystack. So with unit tests, I get to test specifically the motor drivers. For example, I know that these motor drivers are going to give me a specific output towards the board, the master board, for a given input that is reasonable. And likewise with the mecanum logic, it's going to give the correct wheel speeds with respect to, how do I want this to move. So that is a extremely important philosophy because it has saved me from massive mistakes. You might have a coder before who has stuff that looks like it works. He has like, I don't know, 10 classes overnight and just, oh, that's Taproot. But he has all of these different data structures and interactions, even comments, and when you upload it to the robot, it has a seizure. And then when you're waiting for him to debug everything between recompiling and testing, etc., using print statements along the entire chain of command, it's just self-defeating. If there is a means of testing the code and there's a means of automating it, especially since we're programmers, we should use it. So this is what that does, is that if anything goes wrong with the code, I know that at least these are correct, that it's giving the right things for translation and rotation, and 0 means it will stay still. This one's with the chassis code. For those of you new to the robotics stuff, it's just the part with the 4 wheels, and the logic just determines how those wheels move, from like how much you want to make the robot move forwards, backwards, sideways, rotate, all 3 at once even, because we're using something called mecanum. So you will see me make mistakes, you'll see me make design decisions that are off, and you'll find me revising those design decisions as well. There will be mistakes, but what is more important than writing code that works is being able to understand how to correct code that doesn't work, and also correct code that is difficult to understand. So that is the introduction to the 2025 Fang Robotics Infantry Devlog. And you'll see a lot of hours. You'll see the hours that I put into this project as well. Programmers need to be patient. If you have very little patience, then this is not the right field for you. To be honest, I don't think the STEM field in general would be the field for you, because things will not work. The very thing which you pour in hours of your life into will likely not work the first time. Like, when I upload this code to the robot, even though it's the beta version and they have, we haven't had the materials shipped to us yet, I'm not expecting this to work. If this works perfectly, I'm going to be extremely surprised. But if it doesn't work, I know what has been tested and what has not. And 90% of this code has been tested, which means I can quickly trace, instead of having to go through that 90% which, would not have been tested. I can just focus on 10% of the code. Because coding blind, and it's a term I coined, apparently, I guess people ask, like, what do you mean by coding blind? Means that you're coding for something that you don't have access to testing. That means that I'm coding without having any of this being tested on a physical robot, which is the use case. So one way to code blind is you write all of the code and you pray or hope. The other way that I've found much more useful is to write unit tests. And here's an example of like stuff being not ideal. So I'm doing a lot of code duplication here for each test case. And I would say the most egregious violation of the don't repeat yourself principle would be, let's see, Mechanum, is it? Yes, Mechanum calculator. This is 200 lines of code. And, well, technically rightfully so, because this is used, the main purpose of this class is to test the Mechanum logic and just wrap all of that testing logic inside that, theoretically it's giving the correct answers. I know physically the world is wibbly wobbly, but if your theoreticals are all right and your model is reasonable, then if it's good theoretically, then it should be sort of good enough in real life. So when I ended up testing the field Mechanum logic, I think I mentioned this before, this is around 60 lines of code. So for each test case, if I did this the old way, that would be 60 lines of code. And so 16 times 60 would be 16 times 60, 960 lines of code. Not including the headers, but just all of this here. That would be an almost 1,000-line file. And if we're also debugging the tests, because you want to make sure the tests are reasonable, because if, like, for example here, it turns out that there are rounding errors that we just have to deal with. Fortunately for our use case, we don't need it within like 16 decimal places. Like 12 decimal places is still enough accuracy for this use case. The banking world, probably not. But yeah. So to wrap up, this is a raw recording of me programming in order to give you an idea of what it is like to use these skills that you used in the tutorial in the field. The field is going to be messy. The field is going to be imperfect. Field testing, field work is never as clean as the lab. But through knowing how to correct your errors, having a reasonable amount of chaos if you have to do something janky, like before I found out about parameterized tests, there's an order still. I didn't put this into a big 200-line jumble. It still explains what does this do. It tests its logic in regards to how well it can interpret a command on moving counterclockwise, and the variance, wheels, different chassis size, etc. Now, I'm probably going to give this to a newer dev to learn how to refactor, or we're just going to keep it this way because I am relaxing the code standards for tests, because I understand that not everyone wants to deal with standard or STD, get 0, get 1, 2, 3, etc. And the important part is, usually if you're testing something that's small enough, let's see, it's really not too cumbersome. And it will just help them get into the habit of testing. And eventually, yeah, at some point, if they've been coding for like 5 months, I will expect them to improve their skills to not repeat themselves, because again, this would have been 1,000 lines. But that's the leeway, again, ordered chaos. Just because you need to have some chaos or do something a bit janky doesn't mean that you have to make it ridiculously chaotic, something that you will regret in the middle of competition when you're trying to find out what's going wrong, because you ask the engineering team for 2 weeks or 1 week of just having the robot to test, and it's the night of, and they barely finished the robot. That happened to me in real life, but and people ask me why was I calm? Well, because one, you kind of accept things not working in programming, and number two, I did what I could. And finally, for those of you wondering why this one is in the red, we have to adjust the configuration because this is in testing configuration. So if we put hardware, it's all right. But testing configuration? Oh, wait. I guess it doesn't have any errors now. And that's the reason for this is because whenever you're doing it for testing, the firmware developers had this really elegant way of placing in mockables, because using mocks, which are fake objects that basically, like, let's say you have like a board, right? And you're trying to flip a pin on and off. That needs to run on an actual piece of hardware. So that's difficult to test in an automated fashion. However, if you have code that interacts with the board and you're just trying to test, is it sending the board the right commands? Then you can make a fake board that has these fake functions, and you can check from the board mock what kind of functions were called during the test, and also whether or not it passed the right value. So for example, in this test code here, this is using a mock. The drivers essentially is just the board, and drivers, that is how you access it. And so when you say like drivers.pulse with modulation, write this kind of duty cycle, etc., this will wait to see if it got the correct call. Motor.setSpeed. This driver, oh, there we go. So test configuration does not include the Google test stuff. So that leads to, of course, a crash. But I keep typing Control-Shift-N. It's because my control key on my mechanical keyboard's kind of broken on the left end, so I have to do this awkward Control-Shift-P, which my hands don't like. If we do there, it changes the code sensing and telesense, that fancy jazz stuff. So right here with the mockup, this motor.setSpeed. And I guess since we're doing introduction and it's generally finished, I think this probably needs to definitely be documented in multiple places, because this is very useful if you're wondering about testing. And this does violate the single responsibility principle. But why not? I guess in this case. So taproot, if we go here to test, tap, and we'll just go to like motor, DGI motor, test. Let's see, that's, no, mock. So this is the mock for their inertial mass unit sensor. So this just creates a class that will take the same values, implement the same interface, but it does nothing, because the point is for you to check in the test that if it got sent the correct commands, because it's, when you're using encapsulation, it's difficult to check it otherwise. So if we go to definition here, you will notice a keyword called mockable, and you might ask, okay, how do you add a keyword into C++? You don't. This basically is just a define, but it's meant to look more natural. So in order for an object, a class function member, to be mockable, because how you implement mocks is that they inherit from the class that they're simulating. You needed all these functions to be virtual. And all you need to know is that whenever something thinks it's using the class that it's inherited under, you can still pass it even though it's not that class, since it inherits from this class. It has the same sort of functions. You can call the same. When you call the functions, it'll call these. However, in C++, virtual functions are required to do this, because if not, it's just going to use the instructions for the base class. The theory behind this and the reason why this is an issue, of course, is not known to Java programmers. Not necessarily to roast them, and to the beginner, this, you'll eventually get curious enough to know why this is necessary. But what was elegant that the Arizona University Washington did was virtual functions do have slightly more overhead than non-virtual functions. And yes, we could probably make it all virtual and not have too much of a consequence to deal with, roughly speaking. But if you are trying to optimize stuff for embedded hardware, there are cases where these do need to have a performance gain, and since it's the function that's being called so many times, it doesn't make sense for it to be a virtual function, and you'll find a massive speed increase. So the other traditional way that Google says is through templates. And if you don't know what templates are, it's a very useful feature, but the syntax can get quite cumbersome at times. So we'll have here in data, so template. Oh wait, screw that. So just an abstract vector. So this type is just an unknown type, but if I put in unit, let's see, where is this called? Mecanum, rope, field mecanum logic. So if we go here to go to definition of velocity 2D, it uses the type meters per second. And so those X and Y's could be a string, but in this case, this data structure uses meters per second. So you would end up making a template under an interface for whenever you use this mockable class, and it's just more cumbersome because you have to just do so many different things. What the Arizona University Washington did, and I feel like Google should just encourage this, is just use the mockable keyword. If I could find where it is. And it's just simple. Let's see, where is it? Guess I'll have to hunt for it again. So tap test mock. We go to definition. Oh. All right, and then we have mockable. I guess we do have to make sure that this is virtual then. All right, we have a virtual destructor for all of our classes. Okay, there we go. So essentially, if we say that this is mockable, and it is a testing, we're compiling a testing version of this code, it will make that function virtual. So mockable just gets replaced with virtual. However, if we are not in a testing environment, these mockable functions will just disappear into nothing. And so it will just be a non-virtual normal function. And so that's important to know if you're seeing a bunch of mockables, because I am gonna start incorporating this into the whatever, especially the motor drivers, just to get all of the commands to be tested properly. Because one, we don't have a robot, and number two is just a pretty good idea. Because how I did it when I was in high school was that I used a print statement. I moved the joystick around. If the string of print numbers looked reasonable, then I moved on, and hopefully I don't have to edit that code again. And if I found a bug, I'd trace it. But this is a much broader scope, and we have less time because in that case, I also did have a physical robot, the previous year's robot, to test certain stuff like the chassis. In this case, we have zero robot. Our robot's thin air right now. It's not quite thin air. We had all the stuff 3D printed. We're getting metal parts shipped to us, but we do need those parts to make it real. Anyways, that concludes the introduction. The re-recording, because I thought that the Bluetooth earbuds would have worked better in a more portable environment setup, because sometimes I want to code outside of my bedroom. But obviously the introduction should have much better sound quality. So, Raven, Asher, Raziel, I guess this is where I'm supposed to say I'm your host or whatever people say in these official-esque series of videos or multimedia, whatever. And you will see mistakes, but you will also see ordered chaos and recovering from mistakes and the gradual reduction of chaos through reiterating and the reduction of bugs from the very start through unit testing. Have a nice evening, morning, afternoon.